Your favorite artificial intelligence models are starving right now. They are incredibly hungry, and they are consuming the global power grid at an unprecedented, terrifying velocity. Every single time you generate a synthetic image, summarize a heavy document, or run a complex coding macro through a massive language model, you are burning real, physical electricity. Consumers treat cloud computing like an invisible, ethereal concept floating in the digital sky. The harsh physical reality hits much closer to ground zero. The cloud is literally just millions of humming, red-hot silicon processing units stacked inside colossal, steel-reinforced data centers. And those colossal server farms are aggressively draining local municipal power supplies at a record pace. Industry analysts highlight a massive infrastructure collision vector approaching fast. Global electricity demand from hyperscale facilities could effectively double within the next 36 months alone. Traditional municipal power infrastructure simply cannot scale fast enough to meet this skyrocketing silicon appetite. Standard renewable solutions face severe, unavoidable physical limitations. Solar arrays require vast geographic footprints and rely heavily on battery storage that inevitably degrades over time. Wind turbines offer unpredictable uptime, creating fatal vulnerabilities for critical 24/7 server availability. Fossil fuels generate unacceptable regulatory penalties and completely destroy corporate zero-emission sustainability targets. Silicon Valley executives face a brutal, uncompromising mathematical wall. These tech conglomerates possess infinite capital resources to manufacture next-generation hardware chips, but zero reliable electricity to actually switch those machines on. This severe bottleneck threatens to completely derail the next massive leap toward artificial general intelligence. If server farms cannot secure guaranteed, uninterrupted gigawatts of stable baseload power, the hardware innovation curve flattens permanently. Major technology leaders realized this terrifying vulnerability months ago. They quietly abandoned their reliance on legacy utility providers and outdated distribution networks. They decided to construct their own independent, high-density power grids from scratch. Welcome to the absolute dawn of the nuclear-powered artificial intelligence era. This is NeonSync AI, and we are unpacking the most aggressive infrastructure pivot in modern computing history. Break it down. To understand this escalating crisis, you have to look deep inside the server rack. Modern deep learning architecture doesn't run on standard central processing units. It requires massive, synchronized clusters of specialized graphic processing units, currently dominated by engineering powerhouses like NVIDIA. These advanced chips are undeniable technological marvels, but they act as extreme thermal engines. A single premium GPU pulls roughly 700 watts of power under heavy computational load. That is mathematically equivalent to running a standard microwave oven continuously, 24 hours a day. Now, imagine stacking 100,000 of those actively running appliances inside a single windowless building. The sheer electrical draw is completely staggering, but that calculation only represents half the equation. For every single watt of power you pump into a processing chip, you generate an equivalent amount of blistering heat. If you fail to extract that thermal energy instantly, the expensive silicon physically melts down. To prevent catastrophic hardware failure, modern facilities must deploy aggressive industrial cooling systems. Giant liquid cooling loops, massive chilled water reservoirs, and heavy-duty localized air conditioning units run constantly. Frequently, these complex thermal management systems consume almost as much electricity as the processors themselves. When you combine the core computational load with the mandatory cooling requirements, the consumption metrics become terrifying. A single, next-generation artificial intelligence data center easily requires over 1 gigawatt of continuous, uninterrupted power. Put that massive number into perspective. 1 gigawatt provides enough baseline energy to sustain an entire mid-sized American city. When a technology conglomerate attempts to build a new billion-dollar facility, local utility regulators immediately panic. They understand that plugging this digital beast into the existing grid will inevitably cause rolling blackouts for surrounding residential neighborhoods. Legacy power plants simply cannot handle sudden, massive consumption spikes without completely collapsing the fragile transmission network. Substation transformers would blow out, and aging high-voltage lines would literally fry under the immense current demand. Consequently, tech giants currently face brutal, multi-year delays just waiting for grid expansion approvals from slow-moving regulatory commissions. In the hyper-competitive artificial intelligence arms race, waiting 5 years for a municipal grid connection equals total corporate death. Industry desperately needed a radical, off-grid solution that could be deployed rapidly and reliably anywhere on Earth. Enter the ultimate heavyweight champion of modern power generation, nuclear technology. Silicon Valley is quietly abandoning the traditional notion of sharing regional electricity with the general public. They are pivoting aggressively towards small modular reactors, commonly known throughout the industry as SMRs. Unlike the massive, terrifying concrete domes built during the tense Cold War era, these next-generation reactors are remarkably compact. They are meticulously designed in ultra-secure, centralized manufacturing facilities and shipped smoothly via standard train freight. Executives can literally drop a fully functional nuclear reactor right next to a rural server farm. Because they utilize advanced coolants like molten salt or liquid metal, historical meltdown risks are statistically negligible today. These modern designs are strictly physics-driven to safely shut down autonomously during any unexpected anomaly, completely without requiring human intervention. Recently hired the former director of nuclear materials from the prestigious Tennessee Valley Authority. They are aggressively pushing to integrate next-gen microreactors directly into their sprawling Azure cloud infrastructure pipeline. Amazon recently spent an eye-watering $650 million to purchase a massive data center campus in Pennsylvania. That specific piece of premium real estate sits directly adjacent to the famous Susquehanna Steam Electric Station. Amazon will literally bypass the crumbling public electricity grid entirely, drawing carbon-free nuclear power directly from the reactor source. Broad implications of this unprecedented private infrastructure acquisition are absolutely profound and drastically shifting the entire data market. For the very first time in recorded human history, private internet corporations are acquiring their own dedicated atomic power sources. This is not some distant science fiction fantasy located multiple decades away from viable commercial realization. Governing regulatory bodies like the Nuclear Regulatory Commission are actively reviewing commercial applications for these exact microreactors right now. Technology titans clearly understand that whoever decisively solves the baseline energy equation first wins the entire race to artificial general intelligence. If you control a dedicated, localized nuclear power facility, your foundation models can train relentlessly at maximum required capacity. Engineers never have to defensively throttle compute thresholds during peak municipal energy hours or brutal summer heat waves. Your data center effectively becomes an unstoppable, sovereign digital island, completely immune to external municipal grid failures. The sheer scale of this aggressive infrastructural ambition, exactly how seriously big tech views the approaching future of algorithmic supremacy. But what does this radical, unprecedented infrastructure shift actually mean for you as an everyday consumer? Why should anyone care if their language model is powered by a controversial uranium core or a generic solar farm? The immediate technological answer essentially boils down to two critical user factors: latency speeds and advanced feature availability. As complex artificial intelligence agents become fundamentally integrated into our mobile devices, autonomous vehicles, and surgical robotics, speed truly matters. We are aggressively moving toward a high-paced world where digital assistants perform complex reasoning tasks in absolute real time. If the underlying server facilities suffer from unpredictable power throttling during peak residential energy hours, your workflow will inevitably suffer. A fully nuclear-powered data hub strategically guarantees zero performance degradation, regardless of outside severe weather conditions or fluctuating grid status. Beyond mere processing speed, this aggressive energy independence effectively shields the tech industry from devastating geometric hosting cost increases. Currently, raw natural gas and municipal electricity prices fluctuate wildly based on turbulent, unpredictable global geopolitical conflicts. Those highly erratic utilities are ultimately passed straight down to you through increasingly expensive monthly software subscription tiers. A localized microreactor produces steady, highly predictable electricity at a securely locked-in operational baseline for several decades. This solid financial stability ensures that premium algorithmic tools remain relatively affordable, rather than becoming exclusive luxury commodities for the elite. However, this massive, unchecked privatization of nuclear capabilities also creates some deeply concerning regulatory nightmares for federal watchdogs. What realistically happens when a profit-driven private tech corporation controls a completely autonomous grid and handles proprietary atomic material? Are citizens perfectly comfortable letting software companies manage advanced uranium supply chains under the thin guise of rapid technological advancement? This profound seismic shift fractures the traditional, historical model of heavily regulated, publicly accountable municipal utilities serving the common populace. We are essentially witnessing the rapid, unprecedented formation of sovereign corporate nation-states entirely powered by their own private atomic hearts. The distinct boundary dividing digital software engineering and heavy physical global infrastructure is permanently dissolving right before our very eyes. The active nuclear acquisition race represents the final, critical infrastructural puzzle piece required to realistically achieve artificial general intelligence. Silicon Valley is deliberately and systematically removing the only physical bottleneck that could potentially throttle their ambitious evolution timeline. We are officially stepping out of the theoretical software experimentation era and aggressively entering the hard-tech physical implementation phase. The tech conglomerates that successfully secure reliable atomic energy contracts today will completely monopolize the digital intelligence markets of tomorrow. Those struggling startups who mistakenly rely on traditional municipal power grids will inevitably be choked out by escalating latency and exorbitant electricity bills. Modern battle lines for the future are no longer being drawn exclusively in lines of proprietary, underlying code or neural algorithm weight. The new competitive frontier is fiercely territorial, rigidly geographic, and fundamentally locked to high-density quantum power generation capability. As we carefully watch titans like Microsoft, Amazon, and Google scramble to deploy experimental microreactors nationwide, one reality becomes crystal clear. The upcoming digital revolution will not be softly powered by the gentle blowing breeze or the warm afternoon sun. It will be fiercely driven by the relentless, invisible slitting of heavy uranium atoms operating in pristine physical isolation. This massive transition practically guarantees that artificial intelligence networks will soon possess more dedicated, sovereign energy resources than many developing human nations currently enjoy. Are you genuinely prepared for an approaching future where predictive algorithms dictate international energy policies and essentially command their own nuclear power plant? Sheer, blistering velocity of this ongoing technological convergence is absolutely breathtaking, but it can also feel intensely overwhelming for outsiders. That is exactly why you desperately need a reliable, high-octane signal consistently cutting straight through the chaotic, breathless industry noise. If you want to stay consistently ahead of the intelligence curve, you must intimately understand the hidden hardware powering the software layer. Hit that subscribe button right now to immediately join the advancing technological vanguard here at NeonSync AI. We aggressively break down the most critical Silicon Valley shift, cutting-edge hardware component drop, and highly disruptive strategic paradigms daily. Turn on your bell notifications immediately so you never miss another high-speed pulse from the absolute bleeding edge of computing. Let's aggressively analyze and build the future together, 1 minute at a time. Stay sharp, stay focused, and always stay sync.